encryption analysis. So if you want to analyze all of your stuff against looking for these types of attacks that we mentioned earlier, for the TLS, the SSL, Beast, Logjam, etc., then you can go to sslabs.com and get a free scan done against your system. So this is what penetration testers will use a lot of the time, the SSL Labs. So don't confuse this. They need to rename the site because it says SSL Labs, Secure Socket Layer. We know that's defunct. Why would we use it? Because all of our TLS is off. Well, it'll still check all of your TLS as well. So they do have a TLS version in the name already. They're in the middle of transitioning. So by the time this is done, but when you use the TLS URL, it still comes back to this page. So just be aware that they may change it in the future. If you want to Google it, if you can't find it at some time in the future or search for it, you can just search for encryption analysis. So now we're going to discuss encryption. We talked about this a little bit earlier, that encryption is performed by XORing bytes repeatedly. So when you see a lot of XOR operations, you're performing encryption. XOR, we talked about this earlier, is an exclusive OR. So you have the 1, 0, 1, 1. Actually, I think before we were using 1, 1 and a 1, 0. So these two columns are 1s, this is a 1 and a 0. So if you exclusively OR those, the rule is it has to be 1 or the other's a 1, not both. So if you have a 1 and a 1, it's going to be a 0. If you have a 1 and a 0, it's going to be a 1, because one or the other needs to be a 1, but not both. So the XOR operation is a primary algorithm used in stream ciphers. What's a stream cipher? So think of, there's two types. There's block and stream. Blocks are like a file. You chop up the file into a bunch of sections, and you encrypt each one, put them all together, and now you've got your encrypted file. A stream cipher, you don't know how big that's going to be because it's data serially driven over a wire. So if I'm sending you a file 1 byte at a time over wire, that's a stream. So stream ciphers are done on communications like that. You don't know how many bytes you're going to be sending. You can't pad out the block at the end, so they came up with the stream cipher. So just think of it as a bunch of bytes being streamed out, sending a file over a wire, sending a message over a wire, that kind of thing. So HTTPS communications, for example, anything over the internet is a stream cipher. You can also encrypt a file and then send it out over the wire, and it's again encrypted. So, but the difference is you have block ciphers and stream ciphers. Block ciphers work on files and things like that, structured things, and then stream ciphers work on unstructured things, things you don't know how big they're going to be. You're just getting data in and you're pumping it out encrypted. So weakness in XORing, if the key, weaknesses in XORing, if the key is smaller than the data, successful cryptanalysis via frequency attack is possible. So weaknesses in XORing, if the key is smaller than the data, successful cryptanalysis via frequency attack is possible. So you want really big keys. Remember we talked about that earlier? The faster the computers get, the more memory they get, the cheaper it gets. We want longer and longer keys. So symmetric encryption is fast. The same key is used to encrypt that is used to decrypt. So symmetric versus asymmetric, huge test question. You need to make sure that this is clear and concrete in your heads. Symmetric is fast, and the same key is used to encrypt that is used to decrypt. That's why it's symmetric, okay? The same key on both ends. So I have a key, I give you a copy of it, I encrypt the message, send it over, now you decrypt it with the same key. So that works great for web servers and things of that nature, right? So asymmetric keys require large encryption keys. Different keys can be used to encrypt and decrypt. They're not symmetric. Different keys encrypt and different keys decrypt. So it's part of the PKI, public key infrastructure, and we're going to talk about these more in a second. So some symmetric types of encryption are DES, Data Encryption Standard, and we also have triple DES, right? So it's just DES, 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 3 times in a row. That's what that's about. So AES is the newer, more modern. It's Advanced Encryption Standard. So this is what we want to end up using on everything we can that we can possibly migrate to. You want to migrate it over. There's RC, which is the Rivas cipher, stands for the guy's name. There's a stream cipher, again, symmetric, fast over the web. Downloading stream ciphers are fast. Symmetric, so same key that encrypts it and the same key decrypts it. 40 to 2048 bit sizes. It's on its way out. And that's why, because the biggest key you can get is 2048, and that's the smallest you should ever be using. So block ciphers, we talked about these earlier. Block size support of 32, 64, 128 bits. You need to be familiar with these with RC5, and you need to be familiar with these with RC6. Block ciphers, block size supports 128, 192, and 256. You need to know this entire slide for the test. Asymmetric requires large encryption keys. We talked about that earlier. Different keys encrypt. So say I want to send you a file, and we want to talk over encryption through PKI or PGP or GPG. So PGP is pretty good privacy. GPG is GNU Privacy Guard. So it's the same thing. So I'm going to give you my public key. I have two keys. I have a private key and a public key. I can give you my public key, no problem, because all you're going to do is encrypt a message with that and send it back to me, and then I'm able to decrypt it because you included my public key. So, and then I'll do the same thing. I'll send you my public key, you send me your public key, and then I can decrypt with whatever you sent me. So that's how it works. You have to have a key exchange in advance. You need to know that for the test. Which type of encryption requires a key exchange prior to using the keys? Asymmetric does. Symmetric, I can do it on the fly in the first conversation. Asymmetric, you cannot. RSA is the, okay, so asymmetric, Diffie-Hellman, and DSA. For symmetric, DES, RC4, RC4, 5, and 6. For asymmetric, you have Diffie-Hellman and DSA. Again, you need to know all of this. Even the stuff that's like anything in red, which you can see that every single line has a part of red that's colored on here, you need to know this whole entire slide. You just commit it to memory. RSA is a de facto standard algorithm. It multiplies two prime numbers. It's used for encryption and digital signatures. Key size is up to 4096. Supports symmetric and asymmetric encryption, RSA. So it's the standard de facto standard algorithm, de facto standard algorithm. So we talked about this earlier, stream versus block encryption. Stream encryption over the wire or over a serial port. It could also be used on a circuit board. So you have one chip that's sending data to another chip over the bus, and they don't want anybody snooping on the data across the bus. Then you can encrypt it along the way. This is very common to do. And so it's not just over a wire. It can happen anywhere. It encrypts byte by byte by byte by byte. Block encryption encrypts blocks of bytes at a time. And those are more like things like file, memory, that kind of stuff. If you want to encrypt someone's memory, if you want to encrypt someone's hard drive, if you just want to encrypt a file, that's block encryption. An example question you might see, which we talked about some others already, like that whole slide I told you, remember? For messages sent through an entire insecure channel, For messages sent through an insecure channel, a properly implemented digital signature gives the receiver reason to believe that the message was sent by a claimed sender. While using a digital signature, the message digest is encrypted with which key? So for messages sent through an insecure channel, a properly implemented digital signature, the receiver gives the receiver reason to believe that the message was sent by the claimed sender. So I claim to send you a message, and you're going to believe me. So while using a digital signature, the message digest is encrypted with which key? So I'm encrypting it because I'm sending it to you. Which key did I use to encrypt it? Well, I used two. I used your public key and my private key. But on the test, the answer here is going to be the sender's private key. Sender's private key. I'll never use your private key to send you a message. And by the way, the sender's public key is also one of the options, but not the receiver's private key. So don't let this question trick you up on the test. It's the takeaway here, the caveat that you're looking for, the keywords you're looking for are sender and receiver. So when I send you a message, I use my private key and your public key. When you're sending me one, you use your private and my public so that I can decrypt it on my end. you.